Hello students, now we are going to study trends in modern periodic table. This we will study trends in modern periodic table. So this we will study under three heads. First is valency, second is atomic size, and third is metallic or metallic, non-metallic characters of atoms or elements. So under three heads we will study trends in modern periodic table. Valency we have discussed in the previous video also, that as we go down a group the valency remains same. As we go further in a period from left to right, valency increases first to 1 to 4 and then 4 to 0 depending upon the number of valence electrons. So valency we have discussed. Now about the atomic size. I have told you that the size of the atom, it is being taken by the center of the nucleus up to the last valence shell. This distance known as the radius of the atom, and by this radius we can measure the atomic size. The center of the nucleus where proton and neutrons are present, and the outermost valence shell where electrons are present, we can determine the atomic radius. So atomic radius is determined like this. Now what is the size of the atom as we go down the group and as we go from left to right along a period? So first of all we see, suppose I have taken this third group for example, and I am going from sodium to argon or sodium to chlorine and want to determine the atomic size. Just see, in sodium, what is its atomic number is 11. So 11 protons are present and 12 neutrons are present and 12 electrons are present in three shells. So 1, 2, 3 shells are present, and in total 12 electrons are present, 11 protons are present. We know number of proton is equal to atomic number, and this is the nucleus. It is having some charge which is known as nuclear charge. It is an important term and many questions are asked in exam about the nuclear charge. So what is nuclear charge? The charge present on nucleus is nuclear charge. And in nucleus, as proton and neutrons are present, protons are positively charged and neutrons have no charge. So the charge which is present on nucleus must be positive, and it is due to the presence of protons. So it is clear that the charge in the nucleus or the nuclear charge is due to the presence of protons, and neutrons, they are inert, they don't have any charge. So more the number of proton, more nuclear charge. More protons, more nuclear charge. It is clear? Why? When more protons, suppose 11 protons are there, so there will be a force of 11 positive protons. If 13 are there, there is a force of attraction of 13 are there. So more the number of protons, more the nuclear charge. So as we have taken the third period, here 11 protons are there, here 12, 13, 14, 15, 16. So where the nuclear charge will be more? In this period, the minimum nuclear charge will be of sodium, and we are just for some time we are not taking these noble gases as they act differently than the other atoms. So I am taking chlorine. So sodium has minimum nuclear charge and chlorine has maximum nuclear charge. Why chlorine has maximum nuclear charge? Because here the number of proton is 17, here the number of protein is 11. Now what will happen? This is the nucleus of sodium. Now I am making atom of sodium. I am making the atom of chlorine. It is having 17 proton and 18 neutron. And how many shells will be there? There will be 3 shells because in the third period. So again 3 shells will be there. And what is its EC? 287. The number of electrons will be 287. Here the number of electrons will be 281. But we have nothing to do with number of electrons. We have just to see the number of protons. Here the number of proton is 17. So it will have more nuclear charge. That is, these protons will attract the electrons towards them with a great attractive force. Then the 11 will attract the protons towards them. But here the force will be, attraction force will be less. Here the attraction force will be more because the number of protons are more. When they attract these electrons towards themselves and the last valence electrons also, then the size of the atom become less. There is a constriction, the contraction in the size of the atom. As they are attracted with a more force toward the protons, these are electrons, they are negatively charged. So this positive charge attracts the electrons towards the center of the nucleus, center of the atom towards nucleus with more attraction. So there is the size will be less on the right hand side and size will be more on the left hand side. It is due to the attraction forces of protons. As the nuclear charge increases, what we say, that is nuclear charge on the right hand side is more than the left hand side. So the atomic size is less on the right hand side and atoms are bigger on the left hand side. Or we can say, as we go from left to right, the size of the atom decreases in a single period. The period should be same so that same number of shells may be there. If we see the second period, lithium is the biggest atom and fluorine having the smallest atomic size. These noble gases, they have slightly bigger the size of halogens, though they should have smaller size, but as they are unique, they are satisfied, the atomic size is slightly bigger than the halogens. So this is about the this size in along a period. Now we will see the size of atoms down a group. So down a group, I am taking again sodium and potassium. So what will be the EC of potassium? It is having 4 and 19 protons are there and 1, 2, 3, 4 shells are there having 2, 8, 8, 2, 8, yes, 1, 2, how many shells? 4. 1, 2, 3, 4, 2, 8, 8, 1. So this is the configuration of this, what is this? Potassium. So if we go down the group, we can see here only 3 shells are there, here 4 shells are there. So it is naturally, it should be bigger, it is obvious, quite obvious. As we go down in the group, the atomic size increases. It has only 1 shell, then 2 shell, 3, 4, 5, 6, 7. Francium has 7 cells, so it should have a bigger atom. Atomic size should increase. But we can argue that the nuclear charge is also increasing. Here only 11 protons are there, here 19 protons are there. So if nuclear charge is more, it should attract the outermost electrons towards it. The nuclear charge is more. As we go down, the nuclear charge is also increasing. Even then, the size of the atom is more, because these more number of shells overweigh the nuclear charge. Though the nuclear charge is more, but the number of shells is more. When there are 4 shells, it is obvious that this is bigger, and this nuclear charge, this number of shells, it overweighs the nuclear charge. So as we go down the group, the size of the atom, it is bigger, and francium is the metal having the biggest nuclear charge also, but not nuclear charge, having the biggest size of atom in first group. So this is about the size of atom. And about the metallic and non-metallic character, we know that on the left hand side metals are there, and on the right hand side non-metals are there, and in between these I am taking the other pen, a zigzag line, it forms along this zigzag line. These metalloids are present. On this line, on the right of this line, here, this should be non-metals are there, and from the left of these metalloids, metals are there. So boron is a metalloid, silicon is a metalloid, germanium is a metalloid, and then this is polonium, this is tellurium, this is antimony, and this is arsenic. So 1, 2, 3, 4, 5, 6, 7, and here and this they are having quite some little metalloid quality and property, but boron, silicon, germanium, arsenic, antimony, tellurium, and polonium, these are metalloid, and on the right of these are non-metals, and on the left of these are metals. So we are discussing the metallic and non-metallic characters along the period and down the group. See, again I am taking the third period. This is sodium. This is the highest reactive metal. We know sodium, potassium, they are most reactive metals. After sodium, magnesium is there. It is less reactive than sodium. Then aluminium, even lesser, then metalloid, and then non-metals. How this transition from metal to non-metal takes place. So we can see that as we go from left to right, the metallic character, it changes to non-metallic character. In the right hand side you can see silicon is metalloid, phosphorus, sulfur, chlorine, and this is inert. Up to chlorine, these are non-metals. So there is a transition from metal to non-metal. How it happens? In the first video or in the previous video, we have seen what are metals which lose electrons easily. Those are metals. So in sodium, only 11 protons are there, and in the outermost orbit, 1 electron is there. So sodium can lose this electron readily or with ease. So it is having the metallic character. Then we are coming to chlorine. Chlorine having 17 protons and 7 electrons in the outermost orbit. So it is not easy for chlorine to lose these electrons. It can easily gain one electron to have a stable configuration as per the octet rule. So it can have one more electron and will satisfy. So how it is explained here, that the metals, they lose electron readily or easily, and non-metals, they can gain electrons easily. So from going from sodium to chlorine, if they are losing their electrons, they are metals, and they are accepting the electrons, they are non-metals. So the metallic character, it decreases as we go from left to right. These are more metallic and these are less metallic. Or we can say vice versa, the non-metallic character, it increases. These are non-metals. So non-metallic character is increasing and metallic character is decreasing due to the presence of number of different valence electrons. So this is how in periods metallic character, or we can say electropositive character, because metallic character is electropositive character, so it is decreasing. Now coming to the group, we have seen this is only one, so leave this hydrogen. So this lithium having only one electron, all are having one electron in the outer shell, but it is having two shells and it is having 7 shells. So it is easy for lithium to lose the electron. Only 2 shells are present and here 7 shells are there. It is not easy for lithium to lose the electron because there is a force of attraction. Here 7 shells are present, so the nuclear charge or nuclear attraction on the 7th shell is less. It is far away. The 7th shell is quite far from the nucleus. So nucleus cannot attract the valence electron as strongly as in lithium. Are you understanding? So as we go down in a group, the metallic character increases because it has more number of shells, and the outermost shell having the electrons, it is not attracted toward the nucleus. It can easily lose its electron, and when electron is lost, it is known as metallic character. So francium is the most metallic in nature out of the whole table. So in this way we can say that down the group the metallic character increases, or vice versa we can see down the group the non-metallic character, it decreases. So this is how we have discussed these 3 points which are put under trends in modern periodic table. We will discuss some more points and some simple questions and some numerical type also in the periodic table in the next video. This is all for today. Thank you.